Hello friends, in continuation with the previous lecture, now we are going to talk about the conversion of the current into the voltages. It is actually an op-amp circuit and which accepts the input current and gives us the output voltage, and that output voltage which is produced is actually proportional to the input current. So it is also called as the trans resistance amplifier. In converse with this, also we'll be looking at the another case as the conversion of the voltage into the current, and at the end maybe we'll be talking about the buffer amplifier. Okay, so let's say the how we can convert this current into the voltage. The input resistance, as if we look back about a characteristic of the operational amplifiers, as we know that it has infinite input resistance and the zero output resistance, or the impedance we can say in the other way case. And there is a very important concept of the virtual ground also comes into the picture while considering such a kind of the conversion. So here the VP is represented as a non-inverting potential terminal, and the Vn represents the Vn represents the inverting terminal potential at this point. So N stands for the negative one, P stands for the positive potential. Okay. Now, what is meant by the virtual ground? That is, the non-inverting terminal is grounded. So the potential at this terminal is a 0. So Vp is 0. So as we know from its characteristic of the operational amplifier, the Vn point is also at the same potential as the Vp, because the difference between these potentials ideally has to be the 0 one, and this will be amplified at the output. So the difference between these two becomes a 0. So make this difference to be 0. The potential at the Vn point, or the at the inverting terminal potential has to be the 0. So actually there is no exact connection between the or direct connection of the inverting terminal to the ground. It is indirectly connected to the ground through this positive potential, or else the potential at the non-inverting terminal. So this point Vn is also referred as the ground potential, but it is not directly connected. That's why we call it as a virtually ground potential. Okay. Now the here the input resistance is at the virtual ground, and we assume that the source resistance Rs, okay, source resistance here, that is the source resistance of this Is, okay, a current source, is very greater than the input resistance with what we are having at the Ri. Therefore, what happens that there is no current flows towards the ground, so the whatever the amount of the current is directly given to the inverting terminal through this input resistance, and that input current which is flowing from the source is equal to the Is. So I1 is essentially equal to the Is. Thus, by using the property of the inverting amplifier, okay, we can have the I2 is equal to I1 is equal to Is. So I2 is the current flowing through this feedback resistance. So what happens that the ideal characteristic, if we look at the, it has an infinite input resistance. So there is no current flows through into the amplifier. So the whatever the source current is flowing, it is directly flowing through this feedback resistance, and it will be appear at the output voltages. So the I2 is equal to the I1 is equal to Is. So whatever the source resistance source current is there, it will be available at the I2 as well. Thus the output voltage is given as V out is equal to minus I2 RF is equal to minus Is RF. So because I2 is equal to RF, so but here we can consider that the output voltage is nothing but the input feedback resistance times the input current. Thus, what we can have here is the output voltage is proportional to the input source current, and the feedback resistance Rf is a magnitude of the ratio of the output voltage to the current source current Is right? So we have here the converted the input current into the voltages, or else the uh, output voltage is proportional to the source current Is. Now, in complementary with the earlier conversion we use, that is current to voltage conversion, here we'll be using the vice versa, that is voltage to current conversion. The simplest mechanism here also used by using the operation amplifier, that is nothing but the voltage to for the voltage to current converter. So circuit diagram you can see over here, the input voltage is applied to the inverting terminal of the operational amplifier, and then through the feedback we can just measure the output voltage. Yeah, so what we have here is nothing but the I1 amount of the current. I1 is given by V in minus VIN minus VN upon RI. Here VN is nothing but the potential at the inverting terminal or the negative terminal, and VP is nothing but the potential at the positive terminal or the non-inverting terminal. Okay, so this is a virtually sorry, this is a grounded one, non-inverting terminal. So obviously this point will be at the virtual ground as well. So the potential will be same between these 2 points. So Vn is virtually at the virtually ground. So Vn is equal to Vp is equal to 0. We consider here. Therefore, what we can say, so substitute the Vn is equal to 0. So I1 is equal to Vn upon I. But we know that the I1 is equal to I2, because you can see over here that is the same amount of the current is flowing through the R1, and it doesn't current does not go into the operational amplifier because it has a infinite resistance. So the whatever the amount of the current, it just try to flow in this direction. So I1 is equal to I2, and this can be written as I2 is equal to VIN upon Ri. Thus, so this gives us that the current I2 is proportional to the input voltage VIN and is independent of the load resistance, that is Ra, for the feedback resistance we can consider over here. Okay, so now the another topic, that is buffer amplifier. So it is very important amplifier in the electronic instrumentation we can consider here, because it has so many applications in the industries or the electronic circuitries or the electronic industries. Okay, so as we know that the gain of an non-inverting amplifier, okay, gain of an non-inverting amplifier. So before we go for the directly gain of the non-inverting amplifier, just look at this diagram of the buffer amplifier. So what is it? So input is provided to the non-inverting terminal, the VIN, sinusoidal signal, and then the inverting terminal is directly connected to the output. So there is no feedback resistance present in this diagram. So how we can just give the gain of this non-inverting amplifier is nothing but the A is equal to 1 plus Rf upon Ri. So here will be the or R1, okay, so Ri, okay, Rf upon R1. So R1 will be the input resistance, and Rf will be the what we can say the feedback resistance. But there is no feedback resistance present here, so Rf is 0 and R1 is infinite. So we'll have the amplifier that have gain exactly 1, or we can call it as a unity gain amplifier. So in this circuit, RF is a plain, it can be a plain wire or which has effectively zero resistance. It's the simple conducting wire we can place in between the inverting terminal and the output. So R1 is at infinite resistance obtained by not having any connection to the ground at all. So there is no connection directly to the ground. So there is no concept of the virtual ground coming over here. So what we can have here is the R1 is infinite here, and this arrangement is called as the op amp follower or the buffer. So here the input infinite resistance which is not directly connected to the ground at all, and this arrangement is called as the buffer amplifier, or the or buffer, okay, or else we can have the op amp follower circuit. The importance of such a kind of the circuitry is does not come from the any changes in the voltage, but the from the input and the output impedances of an operational amplifier. Because see, you must be thinking that the why we are having just input is exactly coming at the output, then why we are using such a kind of the circuitries. Actually, in this kind of circuit is very important, because input impedance of an any kind of the amplifier is an infinite one, but the output impedance is zero, or the very less. So zero current can drive this operational amplifier, because it will have the infinite input resistance, but the output impedance is zero, or the output resistance is zero. So we can drive the infinitely many circuitries by using the output of such a kind of the amplifier, or the such a kind of the buffer. So thus the what we can have, the input impedance of the buffer is very high, and exactly close to the infinity, and output impedance is very low, just a few ohm. So this will help us to drive the many circuitries present, or in its succession. The input impedance does not load down the source and draw only minimum current from it. Since the output impedance is very low, and it drives the load as if it were perfect voltage source. Thank you.